All right, we're going to continue working our whack-a-mole game here. And so we have our game loop. Well, this is actually our hardware test. Let's come down to our game loop, where we kind of have the basic structure of our game that we're going to expand right now. And so the first thing we want to do is we want to add a couple more functions besides get pressed button. So we want to have a function to track to see, to make sure that all the buttons are cleared. And we want to have a function to see if any button is currently pressed, okay? And so we're going to come up to here, and we're going to make a function called def any button pressed, and we're just going to go for button in buttons. We're going to loop through the buttons, and we're going to check to see if any of them is pressed. So we're going to say if button.value is 0. So if a button is pressed, we're going to return true. And really, we could just use this get pressed button one, but we're going to use this for now. And then we're going to return false, okay? And then we're going to make another function here called wait for all released, okay? And we're going to say while any button pressed sleep 0.1. So this function here is just going to wait until there's no buttons pressed. So anytime we see that function called, we're just going to be waiting for the buttons to be cleared out. And so here in our game loop, we want to start off our loop by making sure there's no buttons pressed, right? Because that could interfere with the game. If we're holding down a button, we're not going to be able to, it's going to immediately process that as the wrong button press or a new button press. And probably we may want to add a timeout here. So we'll say to do add timeout to prevent cheating. Okay? So because you could give yourself a little break by holding down the button, right? That'd be cheating. Okay? So now we're going to, once we wait for the all to release, we're going to pick the next mole. And now we're going to wait for button press. And now we're going to change this part right here a little bit because we don't want to know just if they have the right one. We also want to know if they have the wrong one. Okay, because we're going to advance even if they press the wrong button. Okay. And we're going to say, well, get pressed button. So we're going to say current press equals none. And we're going to say while current press is equal to none, so we're going to keep waiting until we get a button press. And then what will happen is we'll turn that light off. And we gotta say here, we're going to say current press equals get press button. Okay, so we're going to, basically what it's going to do is we're going to wait. We're going to check to see if there's a value for current press. If there's not, then we're going to check to see if there's a button pressed. And we're going to wait 1/10 of a second. And we're going to continue this cycle until we see that button is pressed. Okay? And then once the button is pressed, we're going to turn off the LED. And we're going to say if current press is equal to the index, that means they got it right, and they want to do the beep OK. And then we're going to say else beep bad. Okay? That means they got it wrong. Then we'll add maybe a short delay here before we start the next one. And also we'll say sleep. We'll give them like 0.2 of a second here before we throw the next one out. Okay? And now if we play it, it'll be, maybe we should have a score tracker too. So we're going to say score equals 0. And then if they get it right, we're going to say score plus equals 1. If they get it wrong, we're going to say score minus equals 1. And we'll say if score is less than 0, score equals 0. So that way you can't get negative score. You can get rid of that if you want a lot of negative points. But then what we'll do here is we're going to print a message, and maybe we should keep track of the number of rounds too. So we're going to keep track of what round. Round 1. Round equals 0. And then after the LED turns off, we'll say round plus equals 1. So we add 1 to the round, and then we'll print this message. So we're going to say print. We'll make an F string. Round one complete current score, and then we'll put that score variable there. And maybe we want to maybe instead of having a while loop, we should have it be a for loop, so the game doesn't go forever. So instead of while true here, we're going to say for I in range, and they'll make a variable here called total rounds, and we'll set total rounds to be equal to maybe 20. Okay, and then here, now that we have this total rounds tracker and we have this variable I, we can actually get rid of this one since we're already tracking it. We're tracking in this loop now, and so we can get rid of this right here. And we'll just put I right here. Of total rounds. There you go. And now when our game is over, we can print another statement here. It says something like game over final score. Okay. And so I'm going to play this game real quick and test it. So I'm going to press save to save the file. I'm going to run it. Okay. I'm playing the game here. All right, there you go. Game over. We start with round 0, right? So we want to put a +1 here. to have that show 1 through 20 instead of 0 through 19. And we're in pretty good shape now. Ideally, we want there to be a thing here where if you don't press it fast enough, you also lose. Okay? And so we'll make a variable here called press start. And we're going to get the current time there. And that's going to be ticks underscore milliseconds. So we're going to get the current count of milliseconds. And then what we're going to do here is we're going to do another check. And we're going to say if ticks press start. No, I want to do the ticks diff. So I want to do ticks diff to get what ticks diff is. It performs a subtraction operation for us on the counter. Now the reason we don't want to use this instead of just subtracting ourselves is because the counter here can wrap around, and then doing this diff operation can account for that for us. So we just makes it safer for us. So we want ticks ms comma press start. So this is going to get the difference there. And if that's greater than timeout, then we're going to exit our loop. We can make even a little message here. Print, you took too long. Okay. And then it'll break, and then it'll, in this case, the current press will be none, so it'll count as a losing round. And we'll set the timeout equal to 500 milliseconds. Okay, so I have a half second to do it. And then we won't worry about the timeout here right now, but we can add that later. And then let's see. I think I want to now, I wonder if we want to make it harder as the, as you advance. So I'm going to come up with a little algorithm here. Well, let's test this first. So we're going to save it, and then we're going to run it. Oh. It's kind of hard. I made my game too hard here, so I got a score of 1. We want to make that timeout to be maybe a little longer to start. Okay. And then, yeah, it starts. Maybe we also give them like a little countdown here. We'll go starting game. Just so you have like a, because it starts fast, and then you don't want to lose right off the bat. So we can say for I in range 5, and we can go print 5. We'll go f string and then we'll go like a little time dot, or we'll do a little sleep here, like a half second. 0.5. Okay, and then we will also, let's move this down to here so we get a little countdown. And then let's also do this. So right now we print the index. We probably don't want to print the index. Okay, so we want to stop that. And the last thing we want to do is we may want to update the timeout according to like the user score. So as the game gets, as they do better, we want the game to get harder. So I'm gonna real quick make an algorithm for that, and then we'll put it. Okay, so what we're gonna do is we're gonna update our timeout to be 1200. we'll call this the start timeout, and then we'll make a min timeout of, say, like 300 milliseconds, okay? And then what we're going to do is we're going to actually calculate the timeout. And what we're going to do is we're going to take that start timeout, and then we're going to subtract from it their score, divide by 5, okay? And then we're going to times that, multiply that by 100. So what that means is if they have 15 points, 15 divided by 5 is 3. 3 times 100 gives us, it seems too easy. Let's put start timeout here though instead. Let's make this divided by 3 instead. Okay? So then if their score is 15, 15 divided by 3 is 5. They'll shave 500 off. No, enough of this division nonsense. Let's see, what if we did 2? Yeah, we'll do 2. There you go. We don't want to make it too hard, but then what we'll do is we'll say if timeout is less than min timeout, we're going to go ahead and set our timeout to be equal to the min timeout. Okay? And so now it's going to get faster as you do better. Okay? So we'll save this, and we'll run our game. So we got a countdown, and the game starts. And there you go, I timed out, time out. Okay. And there you go, now we've got a whack-a-mole game. Okay, so you can kind of mess around with it, mess around with the timings, mess around with the sound effects here. You can, maybe put a timeout here where we're waiting for it all to be released. And so the purpose there is I can't just like hold down the buttons. So if I run the game again, I can't just like hold down the buttons. The game won't start until I let go of them, and then it starts. And so if I hold these, I'm holding the buttons down, and you can see here it's not responding to them. Okay? And now it happens. And then if I spam the buttons like press them all, you can see it doesn't count as well. Okay? And so it's a pretty good start to our whack-a-mole game here, and looking to see what you guys do with it.